guys, well thanks for tuning in. I'm sure you're here because you want to see my spin on the wood drying kiln. And I think I got a couple interesting twists, but most of it's kind of taking a bunch of different people's ideas and putting it together into one final product. Obviously, the first thing you're going to need is a freezer. In my case, I have this almost brand new Kenmore that crapped out. So first thing you have to do is gut it. And gutting it means pulling out all of the compressor, condenser, the evaporative coils, all of the stuff inside of the control board. Make sure you've unplugged it first. If you're uncomfortable doing that, or you don't know your local regulations, you don't know what your refrigerant is, have a professional do that, I'm saying, for your safety and protection. Because mine had butane, super simple, nip the cable, let the butane run out, not a big deal. But if you have Freon or any of the other coolants, you can end up with a significant safety hazard. So be safe, know your limits, and if you don't understand how to do it, get somebody who does. That's the best advice I can give you. So basically, gut the freezer is step one, right? Now I've also, we'll close the door here, walk you around the back. That gutting also included removing the compressor, the coils, everything. I'm taking advantage of that duct right there, which was where the condensate would evaporate out into a tray. So that whole space back there is going to be my main wiring cavity and control cavity. And I will put a nice cut piece of plywood over there and screw it in place to seal it up when we're done. But at this point, all you need is a nice used old end freezer that you've gutted all of the components out of. Now, talking to everybody, there are 1,000 ways to do this. I have chosen to use a ceramic heater. This is a 500 watt heater, which in that space is going to give me plenty of heat. I'm going to control that with an Inkbird temperature probe. This one has a 5-foot cord, so everything's going to fit in nice and easy there. And it has the temperature probe we'll put inside the freezer. I also have a Humidistat. I'm going to be controlling the humidity and telling when to turn on and off this teeny little dehumidifier, as well as when the fan moves. I also bought a secondary fan, which is a speed-controlled computer fan, DC with an external power supply, and it's a nice. Can't do this with one hand, people. Come on, you can do it, Tony. It's just a box. You can open it. There we go. So a really high-end computer fan with variable speed control. And when I say high-end, it's easy cloud for Amazon. It's not like the one I already put in there. I'll talk about later in an optional kind of bonus piece of the video. But this is a good fan. I've also used a lot of EBM PAPS life safety fans that are good for 100,000 hours. I've used them in my past career. And I actually inserted one of those into the freezer also. You're also going to want some good extension cord. I like the ones that have a long extension, so I don't have to worry about where I'm going to plant it. I only need these 4 plugs to run everything, power, and a safety override switch with a circuit breaker smart, and a little bit of wire routing tools, and a little bit of thermostat wire. If you have any 2-conductor wire, 18 gauge or better is going to work for most of this project. I also have a little power supply, which is just a recycled power supply to run the other fan. And you have to use that, hold on here, you have to use these other power supplies because you can't use the power supply that's in the freezer. If you try to use the power supply in the freezer, it's running off a control board, and you want that control board powered up, and it's looking for all sorts of other signals before it'll actually turn the fan on. So just get yourself a 12 volt constant voltage power supply. It'll supply the current the fan needs to run. For the dehumidification process, I'm actually going to add a dehumidifier. You don't technically need one. A lot of people just drill some holes in the thing, suck some air in and out, and try to monitor when they turn the fan on and off based on humidity. I'm going to be turning this humidifier off, on and off with the actual relative humidity in the tank, and give me a chance to suck the water out rather than vent it into my shop or suck humid air into the freezer. So we want to be able to really control that environment. We're going to set our Humidistat to 50% humidity, and we'll turn this on whenever it climbs above 50% to suck that water out. It's a small tank. It's not huge. It's about 2 quarts. So we'll be able to, have to dump that every now and then. But when it gets full to the top, if you're not around to empty it, it'll just shut off. So worst case scenario is you got a little bit of water there. Cheap. All of the stuff here for the whole build will be in a little parts list at the bottom of the link in the video description, so you guys can pick up the individual parts I used if you're interested. And of course, that will be an affiliate link. I have to be honest about that. I will make a little bit of commission if you guys decide to go this route. Okay, first thing we're going to do is get over to the freezer and wire up the first transformer. So as I mentioned earlier, I have this cool hole here is where all the condensate drained out into a pan. I'm going to use that hole to run all the wires into the tank. So right now I'm going to fish up the 12-volt wire for this fan through that hole, and then we'll wire it up. So once we have the wire fished up through the hole up there, we're just going to attach the positive, which in this case is the center shielded wire, to the red wire, and the negative, which is the outside unshielded wire, to the blue wire. And we're just going to use small wire nuts for that. So almost everyone's got a couple of spare wire nuts sitting around. And again, this is going to be low voltage DC. We're not worried about a bunch of current or sparking or arcing or anything like that. We just need to get a good connection on our wire nuts, and then we'll put some electrical tape over these to secure them in place. And before we do that though, we will come around and we will test it by plugging it in. We should be fine. Simple as that. Now there's plenty of cool YouTube videos about doing basic low voltage wiring. I'm not probably your best source for that info, but let's go ahead and plug it in and see how the fan works. So as you can see, our fan is sucking air in. Let's blow it out up here and up here. So that fan's going to be on all the time. That's going to be a non-stop circulator in there. It will not be attached to any of the controls. So we're only going to use that to keep the air moving around, not for our primary air mover. So what I've done here is I've taken my Amazon Basic ceramic heater, 500 watt, and I've glued with some CA some 1-inch riser blocks around the back. So this one is not sticking. I'm going to have to probably get more gluey. But either way, we're going to glue these down. I might use some VHB if it's not going to stick to this. And that'll lift it off the ground, provide enough air to pull up from the bottom of our unit and blow the heat up through it using the fan built into this, as well as the exhaust fan that we've already incorporated into the tank. Now this also has a safety switch here. It's a tilt over switch. So we're going to have to bypass that or tape it flat. And my guess is I'm just going to tape it flat with some duct tape, and that way it can operate on its back. See, we got the heater running, a lot of heat coming out, 500 watt heater. Now if I lift it back, if you guys listen, turns off. Turns back on. Turns off. So having it upside down like this, we're gonna have to deal with the switch. So all I'm gonna do is get a little piece of wood and some duct tape, and we'll flatten that out. What we have here is some Gorilla Tape, little black, ripping off a small section of that. I have a little piece of wood to hold it flat, putting that in the center of the tape. We'll actually hear it turn on when we push this in. We'll tape it and tape it, and that should take care of our safety requirement right there with the tilt over switch. Now, since we're not worrying about this catching fire at anything, it's going to be inside of our box. It's on top of stands. It's sucking air from the bottom, blowing hot air out on top. That little box should take care of our need there. So in the inside, I've just wrapped the temperature probe around the edge there so I don't have to glue it up anywhere. It's hanging about 3/4 up from the total height. And it's just a small hole in the back corner there, drilled into this direction and then in from the other side to run the temperature probe in. So all you can see there, we'll go around and take a look at the other side real quick. So I have the heating and cooling plug from the Inkbird, which is right here. You can see currently inside the process value is 79.8 degrees, and I have the set value to 85. So it would be turning the heater on inside there right now, as you see the heat lights on there, because we're below our set temperature of 85 degrees right now. So now I'm going to install the heater, which means cutting off the plug, running it through our chase in the back, rewiring the plug and plugging it in right here to our heating element. Sorry, it's upside down, but that's how it works around in here. And we'll plug that in there, and then it'll turn our heater on. See, our heater has turned on to raise the internal temperature to 85. I'm going to go ahead and close the door and see how long that takes. We're at 79.5 right now. So we're closed up nice and tight. Come around the back over here. Got it plugged into the heating side. And we can see our temperature right there. So we have 6 degrees to overcome. Heating is currently turned on. So we'll come back and check in just a second and see how long it takes. So I've turned the heater off, but you can see it's continuing to climb. So we'll see where the climb ends. Power's off to the heater, so it's just the time for equalizing on the actual temperature probe. So got all the way up to 88 degrees. Still climbing a little bit. So by the time it gets to 85, just the amount of heat left over from the heater as it cools off still lifts it up. I'm hoping it doesn't go above 90, and that way it'll take quite a while for the heater to kick back on when it drops down to 85, below 85 again. As you can see, it's been holding temperature for quite a while, not making any change. Still has cooling powered on right now if I wanted to add it into the fan. But since we're going to have the dehumidifier connected up on the other side, we have a fan circulating inside right now. I don't think we need to cool below 88.5. And now we have our heater, our dehumidifier, our circulating fan, and our sensor for the humidity down there, which we'll relocate after you put the cover back on, and our sensor for temperature up high. So heat rises, and the humidity should be relatively stable with the air moving, so we can leave the sensor near the bottom. So I'm getting ready to put the cover back on, and I'll bring you back and show you the controls. Oh, there you go. It's all put back together. The fan is now sucking up air from down here and blowing it out up here and up here for nice circulation through the whole entire box. So sucking up where the heat is, blowing it back out through the top. Should keep all the air moving. If I need to add another fan, I have one. I just have decided to see how this works before I drill any more holes or hook anything else up. But pretty easy, and that's where we're at right now. I'll take you on the other side and show you the controls. So here's how I've managed the wires here. I've used these little clips here, little metal clips, just screwed in with some sheet metal screws. This one's kind of dangling because it doesn't have a way to mount this upright here. I could probably get some double stick or something here, but it's going to be behind the unit. It's probably not going to bother me too much. I have all of the wires routed down to that central power box. It's got a 30-foot cord in case you need to move it around, and all of the wires for the internals route through that plastic pipe right there. So everything, that's the only penetration to the outside, and it's behind that fan shroud you saw. So I'll probably at some point build a box for that. I really wish that the extensions here were longer for each of the controls, but I mean, they didn't really put aesthetics into it. So I just mounted everything on the side over here. We've got our temperature on top, humidity just below it. I currently have it set for 40% to maintain 40%, or at least kick in the dehumidifier if it gets above 40. We're hovering right around 27% right now, which is pretty good for drying. And our temperature is set for 85 degrees Fahrenheit. When it drops to below 80, it'll kick the heater back on, and it'll stay in a 5-degree window there. For now, that is all I'm going to load in there for our test. And we'll see if how that stuff on the bottom reacts. Those are solid blanks there. They're not cored at all. I'm just seeing how they'll dry, if it affects it. They're all covered in anchor seal on the ends. Then in the middle rack, I've got bowls, trying some stacked, some inside themselves with stickers, a few rounds for boxes. At the top, I have a thin live edge, a couple of small blanks, some black locust, more black locust, little maple, and some walnut. Just see how they all interact, trying to keep them spaced. Obviously, we can move shelves around. We could stack a bunch of bowls this direction. I might be looking for some like dish racks or some cool way to get more space out of it. And I'd love to find one more small rack. This rack down here won't fit up higher with the door closed. So if I could find one more small rack, I would get rid of that bottom rack altogether. So that would give us that. So there's your 18 cubic foot freezer converted into a kiln. Took about a total of 4 hours, and a lot of it was just disassembling safely the old freezer and putting the parts together. This only has one hole drilled in the whole thing, and that's up there for the temperature probe. Everything else was routed through the existing condensate drain. Well, hope you enjoyed that. I hope it was useful and helpful. If you have any questions or comments or something, let me know. Again, there's going to be a link for everything I bought here from Amazon to build this particular version. And I'll give you some updates to tell you how it works in the long run. In the meantime, hope you had a good time to get out there and turn something. Thanks for stopping by. If you did appreciate this, I'd love a like and a subscriptions always help. Those shares go a long way to helping my channel grow. I do appreciate you guys. Have a great day. Get out there and turn something.